Okay, so wrapping up 4.8, doing applications of quad equations. Okay, so remember when we're doing the quad equations, what's a quad equation? One that's highest exponent is x squared, right? And when we're doing that, most of the time you get two answers. Okay, you can get just one, but it's not very it's a lot more rare. So we're going to use the ability to solve quad equations to solve these two problems. Okay, the first one, which is actually number 3 in 4.8, says a wire is stretched from the ground to the top of an antenna tower. So let's look, I'm going to draw out what that would look like. So if you have an antenna tower that goes, to the ground, and there's a wire attached to it. That's what it would look like drawn out. Okay. What this sentence tells me about I'm going to label all 3 of these sides. Okay. The first thing it tells me is that the wire is 35 feet long. So where's the wire? Here's the wire. So that's going to be 35. Then it tells me the height of the tower, here's my tower, is 7 feet greater than the distance from the tower's base to the end of the wire. So in other words, this side is 7 feet longer than this side. So I don't know what those numbers are. That's exactly right. If I call this side my x, this side's 7 feet longer than this side. So it's going to be what? Yeah, x plus 7. So what the shape of this is called a right triangle because the tower connected to the ground makes a right angle or a 90-degree angle. Okay, what we're going to use is, and you've probably heard of it before, but the Pythagorean Theorem. Which is a squared plus b squared equals c squared. Okay, these two sides, the ones that make the 90-degree angle, either one can be a or b. Okay, it just has to have this diagonal, which is called the hypotenuse, has to be your c side. Okay, so following the Pythagorean theorem, one side squared plus the other side squared is going to equal the hypotenuse squared. So let's see, what is this side? X plus 7 squared plus this side, which is just x squared, equals the diagonal side, which is 35 squared. So let's see, what does x plus 7 squared mean you need to do? If I'm going to square that, that means x plus 7 times itself. So I'm actually going to have to FOIL there, right? I'll do it over here. So x plus 7 times itself and then FOIL. So x times x gives me x squared. My outside, right, 7x. My inside is another 7x. And my last 7 times 7 is 49. So now that I have FOILed that, look what happens in the middle. What can you do with these two? Right, combine them. So I have x squared plus 14x plus 49. So that's what represents right here, right? That x plus 7 squared gave me x squared plus 14x plus 49. Bring down this plus x squared equals 35 squared. So if you put that in your calculator, 35 squared gives you 1225. So on the left, I can put my x squareds together, right? They're like terms, same variable, same exponent. So put them together. You've got one here and one here. So you have 2x squareds plus 14x plus 49 equals 1225. So now, once I get to this, I have the like terms combined on the left. What do you notice? The highest exponent of this equation is squared, which means this is a quad equation, which means I can go to my quad program. And remember, if you are online or don't have a TI-84, we found this the other day, what quadratic formula calculator, right? Is that it? Yes.
1225.
Absolutely. Yep. Yeah. So if you don't have a TI-84, you can just Google quadratic formula calculator instead of putting it in the quad program of your calculator. Now, when you have a quad program, before you know what your A, B, and C are, all the terms have to be on the same side, set equal to 0. Which means I need to subtract the 1225 from this side. Okay, so let's see what that gives me. I'll put it over here. Two x squared plus 14x minus 1176 equals 0. So all I did was did the 49 minus the 1225, which gave me minus 1176. So now all the terms are on one side, set equal to 0. So my A is 2, right? 14 is your B.
Negative 1176.
Negative 1176 is your C. So either take that to quad formula calculator and Google, or if you have the program, you would hit this program key, go down to quad, hit enter again, and put in your A, B, and C. So 2, 14, and negative 1176. So like most of the time, I got 2 solutions. I got 21 and negative 28. So what is this X representing? The distance from the base of the tower to the end of the wire, which means one of those numbers actually doesn't make sense. What is a distance not going to be? It's not going to be negative. Okay, you will see the relationship of that number to this problem on this side though. Okay, so my X, which represents here, is 21. The height of the tower is 21 plus 7, so 28. Okay, so it does ask you those 2 questions. It says the distance from the wire to the tower. So from the wire to the tower is 21, and the height of the tower is 28. But let's see what happens on number 4. Is everybody okay on that one?
Yeah.
All right, number 4. The foot of an extension ladder is 7 feet from a wall. So let's see, here's my ladder. The foot of it is 7 feet from the wall. And there's your wall. So do you see how that would draw out? ladder is 7 feet from the wall. And then obviously my wall is a straight up and down. So once again, it's a right triangle. So let's see what it tells me about the distances. The foot of the ladder is 7 feet from the wall. So here's the foot of the ladder. It's 7 feet from the wall, which means that length is 7. The height that the ladder reaches on the wall, so the height that the ladder reaches on the wall and the length of the ladder are consecutive integers. What that means is this one will come right, there'll be the next number up from this one. That's what consecutive integer means. That's exactly right. So this would be your x. This is the consecutive integer after this x, which means just the very next number, and to find the next number, you just need to add 1 to it. So let's see what happens when we set this up according to the Pythagorean theorem. I need this side squared plus this side squared equals the diagonal side squared. So the left, I have x squared plus 49. On the right, I have x plus 1 squared. So just like last time, I need to FOIL that out. So x plus 1 times itself. So if I FOIL that, x times x gives me x squared. My outside, x times positive 1 is 1x. Your inside is another 1x. And my last 1 times 1 is 1. Put your x's in the middle together. How many x's do you actually have? 2 x's, right? So you've got x squared plus 2x plus 1, which is on the right side over here. So it's looking quadratic, right? Why is it not going to end up being a quadratic? Because in the process of moving all the terms to one side, what happens? The x squares are just going to cancel each other out, right? Because if I'm trying to move this one over here, I've got to subtract it off here, which means I have to do that same exact thing over here, which just cancels it on both sides. So now it's just linear, which means just solving for x by isolating it, like we've always done, right? So the equation that I have left is 49 equals 2x plus 1. So what am I trying? I'm trying to find x, right? So I'll just find it. This turned it in once the x squareds canceled, it became a linear equation, which means just solve get x by itself by isolating it. So subtract the 1. So 48 equals 2x and divide by 2. So x equals 48 over 2, which is 24. So here's where x is represented. So it's 24. And then the ladder would be 25. Now be careful on this. This is usually on the final. It only asks you for one answer. The length of the ladder, which is what? 25. It doesn't ask you this length. Okay, so just solving for x didn't answer the entire question, right? If it wants to know the length of the ladder, it's talking about the length of the ladder. Okay, so just be careful on that. All right, that is it. Let me take some rolls real quick.